Hello again to all my friends. Always happy to be here, Mr. Benjamin. Smiling and hoping everyone is well. Today we're going to be looking at chapter 1.3 and the lesson will be factors. Now you might be wondering why there's a rainbow here. Well, first of all, rainbows are awesome. That's why they're here. Second of all, we're going to be using this in our lesson today. Now the rainbow I'm drawing is kind of weird. I don't think anybody's ever seen a green, white, and purple rainbow, but I digress. These are the colors I picked for today's video. Anyways, we're going to review our least or lowest common multiple. This was our previous lesson. Now, if we remember correctly, the lowest or least common multiple is a number, when you're given a set of numbers, 2 to 3, however many, if you list out the multiples of that number, for example, 8 and 3. For 8 we have 8, 16, 24, 32, 40. For 3 we have 3, 6, 9, 12, 15, 18, etc., etc., etc. You can go as long as you want. When you find a number between these two that are common, for example, in this case, we have the number 24. This is our least or lowest common multiple. Now, just to remind, the way we find multiples, if we take our first number, our number 8 here, we multiply 8 by 1, we get 8. 8 by 2 gives us 16. 8 by 3 gives us 24. And we will do the exact same thing with the value of 3. 3 by 1 gives us 3. 3 by 2, or 3 multiplied by 2, equals 6. 3 multiplied by 3 equals 9. And then 12, 15, 18, 21, and so on. If you do that with both numbers, or however many numbers you have, you will find a lowest common multiple. Moving on to today's lesson, we are looking at factoring. Now, as always, we list off our learning goals so we know exactly what it is we want to learn today. We are going to be able to determine factors. Within that, we're going to find common factors of various sets of numbers. And then eventually we will get to our greatest common factor of our whole numbers. Remember this symbol right here? This is our number sign, not a hashtag. Not hashtag. Should hashtag, not hashtag. There you go. That's your comedy for today. So, definition of greatest common factor. The greatest whole number, remember we're only dealing with whole numbers right now, that divides into 2 or more whole numbers with no remainder. Okay, so when we divide a big number, for example, if we look at the greatest common factor for 8 and 12, 8 can be broken down into 1 multiplied by 8, 2 multiplied by 4, or you can reverse these two sets of numbers, so 8 multiplied by 1 and 4 multiplied by 2. 12, you can have 1 multiplied by 12, 2 multiplied by 6, and 3 multiplied by 4. Now you probably won't be able to see those ones on the bottom, so I'm going to write them on the other side here. 1 by 12, 2 by 6, 3 by 4. These will all give you 12. I've also listed them out on the next page here. And you see I'm using my rainbows. Now, I'll explain that in the next page, but I digress. 8 and 12. Oop, made a little mistake here. Let's switch this up. So this is our 12. Now, if we look at our factoring rainbow, how many ways can we make 12? Well, 1 multiplied by 12, 2 multiplied by 6, and 3 multiplied by 4. If you check the math, all of these should equal 12. Now, I am prone to making mistakes, so you should all probably check that just to be sure. And for 8, we have 1 multiplied by 8 and 2 multiplied by 4. So these are our factors. Now, if we look at all of these numbers here, we've got 1, 2, 3, 12, 6, 4. 1, 2, 8, 4. What is common between the two sets? Well, 1 is common. 2 is common. I don't see any 3s here. No 3 here. No 6. No. Oh, there's 4. 4 is common as well. So if we look at both of these sets of numbers, therefore, the greatest common factor is 4. Done and done. Now, I'm going to get back to showing you what that rainbow is. I'm going to change up the colors here. I'm just going to get rid of this whole thing and do it again. So if we look at the number 12, start drawing our rainbow. Have a line like that. Have a line like that. and we'll have a line like that. You know, if you learn nothing else today, you'll learn that I'm not very good at drawing rainbows. I'll draw a big blue one here. Ooh, that's beautiful. So, each side of the rainbow, if we draw an imaginary line, I'm actually going to draw the line here, but I'm going to get rid of it right afterwards. Each side of this rainbow will represent a factor, and in between the factors, we're going to have our multiplication sign. So, if I have the number 1 on this side of the rainbow, we continue along this blue line of the rainbow. What number do I have to multiply 12 by, or 1 by, to get 12? And the answer to that is 12, because 12 multiplied by 1 gives us 12. If we do the same for the number 2, for example, 2 will go along the green line of our rainbow. What number multiplied by 2 gives us 12? 2 multiplied by something gives us 12. And the answer to that is 6. So 6 will go here. Now, the next number for the number 12, the next factor would be 3. 3 going along this purple line, 3 multiplied by what gives us 12? 3 multiplied by 12. And the answer to that is 4. So other side gets 4. And that's where our rainbows come from for this lesson. So you can use this approach for any number. If I change this to 15, for example. 1, 2, 3, they can still stay there, but these numbers here would have to change. I'm going to make this a little more flush. So 1 multiplied by 15. 2 multiplied by 7.5, but that's not a whole number, so we're going to get rid of that. And 3, which has been cut off, let me redraw that 3. 3 multiplied by 5. They all give us 15. You can do this for any number and make a little rainbow out of it. So what? What does this all mean? What's the point of finding common factors? How does this possibly work in real life? If we go back to our previous example of 12, say we are using 12 as a measurement. Say 12 is 12 meters squared. That meters squared, we've seen that before. Meter squared is for area, right? Area question mark? No, area for sure. Exclamation mark. Area of what? Well, say we were creating a sandbox. Sandbox? Question mark. No question mark. We know we're making a sandbox, and we want our sandbox to be 12 squared meters. We have to think about what measurements will make that. We could have a sandbox that is 1 meter by 12 meters. That's more of a sand rectangle. We could have one that is 2 meters by 6 meters. That's the bit better, I guess. Or we could have one that is 3 meters by 4 meters. Now this is probably the most boxy looking sandbox right here. This one here. That's the eraser. This is the one we are going to go with. And that's what factoring helps us with. So try this. We are going to find the GCF of, let's think of some numbers here. Let's go with 15, 30, and 50. That should be okay. We'll try that we'll try that tonight, and tomorrow in class we'll take a look at it. And as always, we say thank you for watching. I really got to change that up because that A doesn't look like an A and that N doesn't look like an N, but that's okay. Thank you. And we hope you have a wonderful day.